Hello student, welcome to today's lessons. When you were in primary school, you were taught counting in base 10. This number system has 10 digits, that is from 0 to 9. Generally, most people use base 10 when counting, and it is therefore internationally recognized. Look at this table of counting in base 10. Areas like computer science, a special number system is used, that is base 2 number system. Base 2 number system contains only two numbers, that is 0 and 1. Days of the week is counted in the cycle of 7, that is counting in base 7. Base 7 contains only 7 numbers, that is 0 up to 6. Counting in base 2 means counting in group of 2s, and such a system of counting is called the binary system. In today's lesson, we are going to look at binary system and some basic operations with binary. Here is a table of counting in base 2, and it is base 10 equivalent and also some explanation. 1 is equals to 1. 1 in base 10 is equals to 1 in binary. 2 in base 10 is equals to 1 and 0 in binary. 3 in base 10 is equals to 1 1 in binary, and the rest of it. This is a continuation of table of counting in base 2. You can pause the video and learn it. If possible, cram it. Here are some basic operations with binary. In addition, in the addition side, we have 0 plus 0 is equals to 0. 0 plus 1 is equals to 1. 1 plus 0 is equals to 1. 1 plus 1 is equals to 1 and 0. While in the multiplication side, we have 0 times 0 is 0. 0 times 1 is 0. 1 times 0 is 0. 1 times 1 is also 1. In binary system, we can add, subtract, divide, and multiply just like the way we can do in base 10. For example, add the following binary numbers. Number 1, 111, 101. Number 2, 1101, 1011. Solution: we arrange it in a normal way we arrange numbers in order to add them. So we have 111 plus 101. So 1 plus 1 is 1 and 0. So we put 0, we carry 1. We have 1 plus 1. We have 1 0. We put 0, we carry 1. We add 1 plus 1 plus 1. We have 1 1. So we put 1 1 since there is no any number more to add. So the answer is 1100. The next one, 1101 plus 1011. 1 plus 1 is 1 and 0. We put 0, we carry 1. We have 1 plus 1, we have 0, we carry 1. We have 1 plus 1 again, we put 0, we carry 1. So we have 1 plus 1 plus 1, we have 1 1. So we put them. So this is the result. So, and here the answer is 11000. Here is an example of how we can subtract in binary. Subtract the following binary numbers. Number 1, 111, 110. Number 2, 1101, 111. We arrange them the normal way in order to subtract. We have 111 minus 110. So 1 minus 0 is 1. 1 minus 1 is 0. 1 minus 1 is 0. So the result of 111 minus 110 is 1. We have 1101 minus 111. So we have 1 minus 1 is 0. Then 0 minus 1 cannot, so we borrow 1. We have 10 minus 1 is 1. So we have, then what is left here now is also 0. So we borrow 1. We have 10 minus 1 is 1. So the result is 110. Here is an example on how we can multiply in binary. We have evaluate 11011 multiplied by 11. Number 2, we have 111 multiplied by 111. Solution: we have 11011 multiplied by 11. we arrange it the normal way we used to multiply numbers in base 10. So we have 1 1 0 1 1 multiplied by 1 1. So 1 times 1 1 0 1 1 is equals to 1 1 0 1 1. Then we put it, then we move to the next placed number. We have 1 times 1 1 0 1 1 is equals to 1 1 0 1 1. Then we add the first one. We have 1 plus an empty space under it, so 1 plus 0 is equals to 1. Then the next one we have 1 plus 1. 1 plus 1 is 1 and 0, so we put 0, we carry 1. Then we have 1 plus 1 again, we put is 1 and 0, so we put 0, we carry 1. We have 1 plus 1 again, we have put 0, we carry 1. We have take the 1 to the next level, where we have 1 plus 1 plus 1, we have 1 1, so we put 1, we carry 1. So we put 1 again, 1 plus 1 is 0. Then there is no any more number to add, so we put our remainder, which is 1. So the result is 1 0 1 0 0 0 1. So the next one is 1 1 1 multiplied by 1 1 1. So 1 multiplied by 1 1 1 is 1 1 1. Then the next number, 1 times 1 1 1 is equals to 1 1 1. Then the next number is 1 times 1 1 1 is 1 1 1. So we add, we have 1 plus an empty space, we have is equals to 1. Then we have 1 plus 1 is 0 1 0, so we put 0, we carry 1. So we have 1 in 4 places, so when we add them we have 4 in that, which is 1 0 0. So we put 0 2 of the zeros, then we carry 1 to the next place value, which is that one that is alone. So this 2 1 1 1 plus 1, we have 0 1, so we put 0, we carry 1. So when we put the 1 here plus the other one, we have 1 1. So since there is no any number to add, so we have 1 1. So the result is 1 1 0 0 0 1. Here is an example on how we can divide in binary. Evaluate 1 0 1 0 1 divided by 1 1 1. 2 1 0 0 0 0 divided by 1 0 0. Solution. Division can be done using repeated subtraction, just as in the case of base 10. So here we have 1 0 1 0 1 minus 1 1 1. So the result, 1 minus 1 is 0. Then the next one we have 0, we borrow 1, we have 1 0 minus 1 is 1. Then here we have 0 also, then we borrow 1, we have 1 0, 1 0 minus 1 is 1. Then here we are left with only 1. So the result is 1 1 1 0. 1 1 0 minus 1 1, we have 0 minus 1 cannot, so we borrow 1, we have 1 0 minus 1 is 1. Then we have the left with 0, so 1 0 minus 1 is 1. Then we are left with also 0 here, so we 1 0 minus 1 is also 1. So the next one is 1 1 1 minus 1 1 1. So 1 1 1 minus 1 1 1 is 0. So we subtract up to 3 times before we get to 0. So that means there is this 0 1 1 0 1 0 1 divided by 1 1 1 is equals to, it's going to divide it 3 times. So that 3 in binary is 1 1. So the result is 1 1. For the second one, we have 1 0 0 0 0 divided by 1 0 0 in binary. Solution. 1 0 0 0 0 minus 1 0 0, that is using the method of repeated subtraction. So we have 0 minus 0 is equals to 0. Then the next one, 0 minus 0 is 0. Then the next one, 0 minus 1 cannot, so we borrow 1. We have 1 0 minus 1 is 1. Then here 2 is also left with 1. So 1 minus 0 is also 1. So the result is 1 1 0 0. So we have 1 1 0 0 minus 1 0 0 again. So we have 0 minus 0 0, 0 minus 0 0, 1 minus 1 0. Then we are left with 1. So the result is 1 0 0 0. So 1 0 0 minus 1 0 0. So we have 0 minus 0 is 0, 0 minus 0 is 0. So 1 0 minus 1 is 1. So the result is 1 0 0. So 1 0 0 minus 1 0 0 is 0. So we subtract up to 4 times before we get the result. So what is 4 in binary, 4 in binary is 100. So if you don't understand all these things we are doing, you can check all the previous tables where you can see the basic operation using binary. You can be able to get the meaning of the basic operations. That is how we add and how we multiply, and also the equivalent, the binary equivalent of all these base 10 numbers, that is from 1 up to 20. We have it in the table, so check the video or go back to the video or repeat the video as many times as possible so that you can be able to understand. Thank you for listening. I hope you understand. See you in the next lessons.